Okay, let's get started. Hello, I'm Ben from the RIT Game Developers Club. Um, so we did a live demo on Wednesday, and I recorded it, and then that file got corrupted, so I'm gonna record it again, but not technically live, I guess. So, here we go. Let's begin. This demo is all about Unity, so it's geared more towards freshmen or beginners to Unity. So what I'm going to be doing is going through an entire project and showing you guys the steps that it would take to make like a basic 2D game. So this is what the final product is going to be. So just hit play here and you can click on these little guys and blow them up and your score will increase. Got some animations going in on them, got animated torches in the background, custom cursor and fonts and stuff like that. So it might seem pretty simple, but it lays a good foundation for you to be able and take this and go do whatever you want with it, add some new mechanics, different enemy types and stuff like that. Gets you started with the physics system in Unity and like the basics of like 2D art, like the parallax layers and stuff like that, and how to import all that stuff into Unity. So yeah, let's get started. I'm gonna start out with a new project actually, just to make sure that everybody's on the same page when it comes to that. So I just opened up Unity and I'm gonna hit new project and then click 2D and call it RGDC demo. Alright, and then just hit create project. So this is running in Unity 2017.1. So if you have a different version of Unity, everything in this should be the same. And if you had just downloaded Unity for the first time, it's going to look different. So let me just default my layout real quick. All right. So this is what Unity will look like if you're a first-time user and you had just downloaded it. So I'm going to show you our GitHub page real quick so that you can go and follow along and stuff. So if you go to this repository right here, there's a bunch of steps to follow and stuff like that, and links to art assets right here, which is what I used. They're from opengameart.org, so they're all under the Creative Commons license. They're pretty good assets, really great for getting started in a 2D game. So just click down here to download those. And if you have any questions about scripts or anything like that, I'm going to be putting this version of the demo up on our GitHub as well. So hopefully that will give you a good reference point. Alright, so what I've done is just download those art assets. So I just downloaded them and extracted them, and they're in this folder here. So what I'm going to do in Unity is create a new folder, and I'm just going to call it art. And then double click on it to go into it, and drag and drop all these assets in there to import them. So depending on your computer, this might take a little while. There are a lot of art assets in here, but they're really, really good. So as you can see, they're all in here, extracted and stuff like that. I'm going to make this a little bit bigger. You can change your project window, like the size of files, going down with this little slider down here in the corner. I'm going to make it a little bigger so it's easier for you guys to see. So what do we want? We want a background. So we'll go into tiles. Let's use water as a background. So this is Unity's 2D mode. So there's these little handles up here that allow you to change between what tools you're using. There's the transform tool, which just allows you to drag stuff around like that, and you can just do that. And there's a rotate tool, which rotates in the world, and there's the scaling tool, which isn't super, like, you can use it, but with the sprite tools that they have, it's kind of silly to use because the sprite tools are a little bit better at scaling and stuff like that. And So if you notice as we scale the sprite, it's kind of stretching and getting distorted, which is not what I want for a background. Instead, I want the draw mode over here, instead of simple, set it to tiled, and then when you pull it, it will automatically scale and tile for you, which is a really great tool, and it's really useful, and people use this all the time. So now you'll see these tabs up here called the scene and game view. Right now we're in the scene view, so this is where you edit things in your game, and this is like how you edit your game world. If I were to press play right now, it would switch us over to the game tab, and we'll see like this is our game. There's nothing in it right now, but that's how you do that. And if you see these white outlines here, that is the bounds of where the camera is rendering. So this main camera object over here in the hierarchy. You can think of this hierarchy as just like a regular file structure. So any object in your game will be in the hierarchy if it's active. So you can just, what I'm going to do is just drag this sprite and make sure that it fills the bounds of the camera so that we don't get those blue bars that we were just getting here. Alright, so now let's put like maybe a little bit of sand down in the beginning so it's like we're on a beach. And as you see here, like moving this sprite behind the other one, it goes behind it. That's because they're on the same sorting layer right here. So everything in a 2D game is going to have a sprite render, and all a sprite renderer does is basically just tell the camera, hey, I need to be shown on the screen. And there's a couple different options for this. So if you want, like, the way that you want your sprites to be rendered, you want to put them on top of one another or layer them in some way. So you can just hit add sorting layer and then a little plus button, and I'll call this like foreground for the sand because it's in front of the background. And I'll just put it on there, and now it renders in front of it. So now what I'm going to do is go back to tiled on here, go up to the sprite tool, and stretch it out. So now let's take a look in our game view. Okay, that looks alright. It's usable, but it's not super pretty or anything. Another thing to notice would be this drop down up here that says free aspect in your game view. This is what aspect ratio you're working in. So if you're like trying to make like a UI system or something and you want to test that it works in different aspects so that it scales properly, this is a good quick way to do that. I'm going to change mine to 16:9 because that's just what I personally like to work in there. Alright, so now that we have our basic environment set up, let's pick an enemy that we want to destroy. How about a fish? A pretty angry fish. So as you can see again, it's on the default sorting layer, so I'm going to add another one. That's called, caps lock on, enemy, just so that I can keep them separate in case I want to sort that enemy layer and the foreground layer differently later. So right now the fish goes on top of that, which I don't really want. That doesn't make too much sense for a fish to be on the sand. So I'm going to go back to my sorting layer and drag the enemy layer behind the foreground layer, and now the fish renders behind the sand, which makes a little bit more sense. So it's fish here over in the hierarchy. If you have something selected in the hierarchy and then you hit F in the game view on your keyboard, it'll focus in on it. So I'd say that's a good enemy to, get started destroying. So what I'm going to do now, we're going to start coding our like basic game logic. So I'm going to create a folder in the project window down here called scripts. And just in case you guys can't see any of these windows or anything like that, just go up to Window and then all of the options here. So like for the hierarchy, if you want another one of those, you can have another one, and it's right there. And same goes for all of these. yeah, so now we have our scripts folder. It's really important to keep your game organized and readable for other people, because a lot of the times, working on projects or even just in game jams, you're going to be on a group project, and it's really important to have other people be able to read and understand your thought process. So what do we want to happen when we kill this fish? We want to just click on it and have it disappear. So that's simple enough. We're going to do create new C# script, and then it'll highlight the text and allow you to name it. So I'm going to call it kill on click, because I want this script to kill any enemy, kill anything that I click on. So what that's going to do is open up Visual Studio, which is my editor. It by default, Unity comes with something called MonoDevelop, and you can change your settings for that by going to edit and then preferences right here, and it'll bring up this dialog box, and then go to external tools, and there's this first drop down here, external editor that you want. MonoDevelop, see in parentheses it says built in. I prefer Visual Studio just because it has a lot of really great debugging tools, and it looks a lot better in my opinion, and I use it all the time. And at RIT, it's really great to get to learn and be comfortable with early, because that's what all of your classes are going to be in as an IGM student. So we're just going to open up this kill on click script. As you can see, let's just go through this, because this is the first time you're using Unity, you have never seen this before. So you can see a couple of using statements on top. Using Unity engine right here is very important, and anything that is going to be a component on a game object, it needs to have that using Unity engine. And using Unity engine will also allow you to use things like time.delta time and stuff like that. And basically you're going to have that on most of your scripts in your game. And this public class kill on click, so that's what we named it in the editor. And then this extends mono behavior here. So mono behavior is just, so you can, it's part of the Unity engine. Mono behavior is super important, and it's basically like, if we want this script to be a component in Unity, it has to be a mono behavior. So what I mean by component is like this sprite render here, this is a component. So this button that says add component, if we wanted to put this script that we just made on our game object, just type in kill on click and it comes up there. So that's what I mean by a component. And every game object, so every object over here in this hierarchy is a game object. You can see that like this little symbol here is like the traditional symbol in Unity for game object. And every game object in Unity is going to have one thing that it just has to have if it's in the world, and that's a transform. So you have to have a transform component on every game object. So just keep that in mind. So now you have your start method and your update method. So start, you can see the comments generated automatically for us. It says use this for initialization. So this method is going to run on the start of the engine. So right when you press the play button in the editor here, then that start method would start. So if I just put in debug.log start method, then, and debug.log is like console.out or printf or something like that. That's just the way that Unity does it, to print out to their console, which by default is right here. Or you can go window and then down at the bottom console. So now we have the debug statement in the start method, and we press play. Yep, start method. So if we had multiple of these, and you can duplicate just by hitting Control D or by right clicking and hitting duplicate. So now we have like a whole bunch of these little fish. We're going to hit play. We're going to see a whole bunch of start method things, because each one of them has an instance of kill on click on it. So that's how the start method works. And then in update, if I just copy and paste this code here, update is called once per frame. So I'm just gonna fix these brackets here. By once per frame, I mean like you always hear about video games running at 60 FPS or 30 FPS and stuff like that. That's frames per second. And so anything that's in this method will be called once per frame. And that can happen like up to like 60 times a second, most is like standard. But if you look here in the game view and hit stats, over in the top right corner, it shows you your current FPS that you're running at. So anything that we put in that update loop would be happening 227 times in a second. So you have to be very careful about what you put in this update loop, and by that I mean like you don't want to put anything expensive, no expensive code in there. So if you have a super complex calculation, you do not want to put it into the update loop because then it'll really ruin the performance of your game. So if we run this now, see, we're seeing update, a whole bunch of times, and that's because we have that debug statement in the update method. So those are just the basics of, every Unity script that you make is going to start out with those two methods. But today we're not going to use these for this particular script. Unity also has a bunch of built-in methods. So one of them is called on mouse down, and that basically just says when the mouse clicks on this object. So on mouse, like, okay, so the method name, what does this mean? So you have your mouse and the engine knows the position of your mouse at all times, but on mouse down, like you click your mouse down, okay, so that makes sense. So whenever you click on your mouse button is down and you want something to happen here. So here we want to destroy this object, but first I think we can just test it with the debug statement. Clicked on this object, and then let's just add in the name of this game object. So do game object, and you can see this little wrench here in Visual Studio. That means that that's like local to this object. And name, so it's a property. Sorry, I forgot the name right. So now whenever we click on this object, it should just print this stuff out to the console plus its name. Alright, so let's test to see if that works. So we expect, well, I'm clicking and nothing's happening. Okay, so the way that on mouse down works is it only works for things that have colliders on them. So it only works for game objects, so in this case our fish. It doesn't have a collider on it, so the physics engine doesn't know that you care about the position of this object. So all you have to do to get it to care would be to add a component and then type in box collider 2D, and here you go. Now you can see a little green squares just appeared around our fish, and that is our box collider. By default, Unity tries its best to like snap it to the image or the sprite that's there, so you can see the size here if you wanted to change that. See, I'm changing this right here, and this collider is moving along with it. I'm going to make it a little bit bigger so that it's a little bit easier to click on. And then I'm also going to add a rigidbody 2D to this object, which tells the physics system that we care about it. So here you can see you have a couple different options in this component, like mass, linear drag, angular drag. Today the one that I care about the most probably is going to be the gravity scale, because if we run this right now, what's going to happen is this fish is just going to fall, because now the physics engine is caring about it, and it's like, hey, this object has a mass of 1 and it's like in the air right now, so it's just going to fall. We don't want that to happen, so we're going to do gravity scale 0, and that's nice and simple, and it'll stay there. And now because we have a box collider, when we click, as you can see, we get those debug statements, and we're getting fish swim 1 as the name of the object, which is correct in the hierarchy. So now that we have that debug statement happening, what do we want to do? We want to destroy this object, so we can just say destroy this dot game object. So now when we click on it, it should just disappear out of the hierarchy completely. It's going to be deleted. Yep, and there it is, it's gone. So that is the behavior that we expect. Now what I'm going to do is make this object a prefab, and what that means is it's kind of like a blueprint. So I have one of these objects, and like in the engine, then you can reference that anywhere and create instances of those objects, and you can make, like, while you're editing, if I have this one fish and I duplicate it, now I have 3 fish. Well, if I make a change to one fish regularly, like if I want to change this color to red, then that only happens to that one game object. But if it's a prefab, and you do that just by dragging the object into the project folder right here, so now that's a prefab, you see this name turn blue. That means that the object is a prefab, and you got a couple extra buttons up at the top in the inspector window that says prefab, apply, revert, and select. So now, if I have this prefab and I have multiple instances of it, and I change something on one, like if I make one like a nice blue or something, that's really bad coloring, but you'll get the point, and then hit the apply button, it makes changes to everything. So that's what I mean by it's a blueprint. So you can make one change and it'll apply everywhere. I'm just going to put that base color to white because that's a tint, and then hit apply. And then I'm going to change the name of this object by hitting F2 after I clicked on it, and I'm just going to call it enemy fish. So that also changed the name in the current game world, and it's really important. Naming conventions are important in Unity. Again, have transparency between you and your team, and also organization. So I'm going to make a folder called prefab, and I'm just going to drag this guy into there. So now we're nicely organized, and we have a little fish that disappears when we click on it. So now it seems like a good point to save the project because we made a little bit of progress. We're getting somewhere. So I'm going to hit Control S, or you can do File, Save, and I'm just going to call this scene main. So whenever you're working in Unity like this right now, what you're editing in the scene, see the scene view is called a scene. So every object in here is stored in your scene data, and you can just save that at any time. So you can think of it as like the folder structure is going to be, and just bring up where I made this project in my Windows File Explorer. I can show you the folder structure. So you can see right here, RGDC demo, that's the project that we made. That's what we called it in the beginning. If you click on that, then this is all the information in that project, and then we go to assets. So that's right here, and the project window is our assets folder. So if we go there, then we have all these folders that we just made. And this scene that we just made, main.unity, and unity scene file. So that's useful. Another thing that you guys might not see on your screen would be this .unity or .meta. Those are file extensions. In Windows, you can do, to get those shown, just go to View and then hit File Name Extensions, check this box. It's very useful. Another thing that I would recommend would be hidden items. So there's none in this folder, but if you're doing development regularly, you should have those two things checked if you're just beginning. Yeah, so that covers that. Now we have our scene saved, and we're ready to move on. So we want these fish to be spawning, right? So like if we look back at our original project here and hit play, they're spawning out at what looks like a bunch of different random positions along the bottom, and then having like forces applied to them to move them up. So I guess right now we'll work on spawning then. So if we just make a new script, create C# script, I'm going to call it fish spawner, and then double click to edit Visual Studio. And sometimes when you make a new file, Visual Studio is going to say file modification detected. Just say, alright, I'll reload the entire solution then. And what that does is that it goes through all the new files that you created, and makes all these links to model behavior and Unity engine namespaces and stuff like that, so that you can reference all of the proper methods and stuff with IntelliSense. So we want to make a new method, just call it private of type IEnumerator. So this is going to be something new. As you can tell, it starts with an I, so it represents an interface. So an IEnumerator, and we're just going to call it, and I'll explain this in a second, so that don't worry. IEnumerator spawn fish, and save up, and we already have an error, and that's because we're not returning anything. So for those of you who are brand new to coding, this is going to seem kind of complicated, but for those of you who know C# and are a little bit more confident in your development skills, then I'll explain this for you guys. Most game engines don't support like actual multi-threading because it's a little bit unstable. Unity actually just added support for that in 2017 with a new version of .NET, .NET 4. But that's still a little bit unstable and a lot more complicated than we need to get with this project. So we're going to use coroutines, which are kind of like baby versions of threads. So when Unity didn't support threads, they made these things called coroutines, and they basically allow you to like wait amounts of time and do more complex functions without it happening like every frame or having to complete within the same frame. So instead of having a really heavy calculation that will have to complete within that frame and drop your frames per second, you can just put it in a coroutine and tell it run until you're done, and then it won't destroy your performance if you do it correctly. Coroutines can also be really dangerous if you don't keep track of them and instantiate and destroy them properly. So I'm going to show you guys how to do that. So we don't need the update loop here. In our start method, in our start method, right when we start the game, we want to start spawning these people. So we're just going to say start coroutine spawn fish. Make sure you get those parentheses there. Simple enough. So now that's going to say whenever the game starts, we're going to start this coroutine to spawn these fish. So what do we want to happen in this spawning fish coroutine? Well, we're going to need a couple fields and parameters up at the top of our class. So we want to spawn a fish game object. Okay, well, we just made a fish prefab right here. So we can reference that in the script by saying public game object fish prefab. And the reason that this field is public is so that you can see it in the inspector. So if you look at all of these components, they all have these fields here like sprite, color, and stuff like that. That is because in Unity's development, they made these public fields and they exposed them to the Unity editor so that you can just go through and quickly edit things in a nice user interface and not have to go back to your scripts and recompile every time you want to make a small variable change. So we want to spawn one of these fish. Alright, so well, how long do we want to do that for? How many fish do we want to spawn? Alright, well, we need to know that. So public int fish to spawn, and we'll just set that equal to 3 for now. And what's another thing that we want? We want, maybe we want waves of fish. So we want to spawn 3 fish and then wait like a couple seconds and then spawn another 3 fish. So we can do that with public float field called time between waves. And we'll set that equal to 2 seconds. So there's an F here because this is of type float. So whenever you're using floats in Unity and C#, you need to put an F after it so that the compiler knows that it's a float. Alright, so those are really all the fields that we're going to need. So let's get started with this actual logic of the coroutine. So how often do we want to be doing this? Well, really we want to do it forever. So we'll just say while true. And now you can see immediately why coroutines can be so dangerous. Because this is just a blatant infinite loop right here if you don't do anything about it. So what I'm going to do is just say at the end, yield return null. So all that's going to do is tell it basically to skip the frame that we're on right now. So it's just going to return nothing, and then it will just kind of run in the background and nothing will be happening. So forever we want to spawn a couple fish. So for int I is less than the number of fish we want to spawn. Oh, forgot to initialize. Equals 0. Cool. Can't type today. I is less than fish to spawn, and then I plus plus. And this is just basic for loop syntax. You know, it's pretty simple stuff. If you don't know about for loops or anything yet, you're probably not ready to start development in Unity. Yeah, so go, if you don't know about for loops or anything like that, go look it up and then come back. So what do we want to do for inside this for loop? We want to spawn a fish. So you do that, you create objects in the world in Unity by just saying instantiate. Now let's read the reference docs here. Instantiate, it wants an object. Okay, well we have that with our fish prefab object, and then a position and a rotation, but there's also 9 overloads. So let's just see if we can just spawn objects for now. Instantiate fish prefab. Alright, simple enough, we can do that. Cool. And then instead of this yield return null at the end, we can just say yield return new wait for seconds, and then give it the amount of time we want between waves, which is just our field there. So now all this is going to do is say, okay, forever, while this like game object exists, basically while this fish spawner class exists, we're going to start this coroutine right at the beginning and say while this object exists, every wave we want to spawn the field for the number of fish that we want to spawn. We're going to create that amount of fish right there with the instantiate, and then wait the amount of time between the waves.